We'll now move on from discussing symmetry of functions to talking about transformations of functions. So we'll look at notions of shifting functions in different directions and reflecting them. Okay, so here is the basic scenario. I have a function f of x that I'm using as sort of like a starting point. And then I will modify it by applying these transformations, by, say, shifting it left or right, or up or down, or applying some sort of reflection to it. So let's make a few preliminaries. So if I have my initial function and I put an plus a in the argument, this acts by shifting the function to the left. If a is negative, it shifts it to the right. So you can think of this as a horizontal shift. When I act inside of the argument, it shifts my domain, so I shift left or right. I can also shift up and down by adding or subtracting outside of the argument. Right? So here's this. If I take my initial function f of x and I add a constant b to it, this shifts the function up or down. Up if b is positive, down if b is negative. So I have sort of two ways of shifting. Inside the argument, which is left and right, or outside the argument, which is up and down. I can also reflect. And again, depending on whether I do it inside of the function argument or outside, will determine the nature of the reflection. So if I have a minus sign inside the argument, this refers to a reflection over the y-axis. If I have the minus sign outside the argument, this is reflection over the x-axis. So it's kind of a lot to take in at once, I think. What I recommend doing, especially if you're working with your graphing calculator in preparation for the CLEP College Mathematics exam, is plug in some functions into the graphing utility. Try adding a reflection. Try adding these translations. And you'll see that the actual behavior is pretty easy to characterize. It's basically exactly what I've said. So let's use this to plot a few functions. So for these, what I want to do is not list many point values. I don't want to make a table and then connect points that I get from this table. I want to use the principles of translating, both in and outside of the argument, and reflecting to understand the big picture here. So f of x equals 3x minus 1. So let's start with the function f of x equals 3x. That'll be our start. And then we'll account for this translation by minus 1. Okay. So here's f of x equals 3x. And then I will shift this by minus 1. Okay, so here's f of x equals 3x minus 1. It's a little sloppy, but essentially all I did was take the function that was easy to plot, f of x equals 3x, and shift it down by 1, according to my translation rule. So we can look at a more delicate example here. I'll have not only a translation inside of the argument, but a reflection. So let me start by annotating my function. So here I have a shift to the right, and then I have a reflection over the x-axis. So how does this manifest geometrically? Well, we can start with the function f of x equals x squared. Now what I'll do is I will shift it and reflect it. So I shift to the right. So this is f of x equals x minus 1 squared. And now, so let me label the blue one. It's f of x equals x squared. And then to get the function I'm ultimately interested in, I will then reflect over the x-axis. So this is g of x equals negative x minus 1 squared. Okay. So here I had to do my transformation rules 2 times. First, I shifted to the right, and then I reflected. We could have reflected and then translated. It would not have been a problem. Let's look at one more. So here I have sort of a combination of a reflection and a translation. So what I'm going to do is I'll write this as minus x minus 1. So first what I do is I plot the function f of x equals e to the negative x, and then I translate that. Okay. So to start, let's plot e to the x. Next, I'll plot the reflection over the y-axis. So here's f of x equals e to the minus x. And then I'll shift to the right. What color to use? So I should get something like this. Okay, so the pink function is ultimately what I'm interested in. This g of x equals e to the minus x minus 1. Okay, now, so again, I had to kind of be careful here. I started by rewriting my original function as something that looked like a reflection and then a translation. Then I drew the function I wanted to commit to memory, f of x equals e to the x. That's sort of my start. I reflected over the y-axis and then translated. Okay? So in order to make this whole process work, I needed to already know what f of x equaled e to the x looked like as a plot. This is one of those plots you maybe would like to commit to memory. Okay? You'll have your graphing utility perhaps, so maybe you could come up with something through that. But I think it's really foundational, knowing sort of basic plots like f of x equals x squared, f of x equals e to the x, f of x equals natural log of x. If you know those in memory, you can get very far using these translations and reflection tricks.